You hear it all the time, 3D prints are weak. They're simply not suitable for functional everyday use. And while it is true that other manufacturing technologies such as injection molding do produce stronger objects, there are many different settings you can tweak in your 3D printing slicer to produce the strongest parts possible on your 3D printer. So in this 3D Printing 101, let's cover them and put them to the test. Let's get started. Here is the part that we'll be conducting our tests on. It's a mount for my cordless drill that sits on the edge of my workbench. The drill is fairly heavy and this mount is going to see a lot of abuse, so I want it to be as durable as possible. And this is the part I've printed on my usual settings. It prints fairly quickly and uses a small amount of material. However, this is not a very strong part. It works, but as you can see, any sudden loads, it starts to fail and delaminate. As you may recall in a previous 3D Printing 101 that we explored 3D printing orientations to improve part strength, but in this case we still end up with a part that just isn't tough enough, even if we use the optimum orientation. So what settings should you change to improve your part strength? Some of you may dive straight into increasing your infill percentage, and while a higher infill percentage does contribute to a stronger part, it isn't the full story. Think about how a pipe can be almost as strong as a solid bar. The part's strength is mostly influenced by its surface. So with that in mind, the first settings we'll change influence how thick the skin of our part is. So I'm going to change our perimeters from 2 to 6 and our top and bottom layers from 3 to 6 also. This means our 3D printer will trace around the outside of the part many more times than it did before, resulting in a thicker surface of the part and greatly increasing the part's strength. It's really important to note here that changing these settings will not affect the size of your part. This is a very common misconception. So if your part is, say, 50 millimeters in diameter, it will stay that way regardless of how many perimeters you give it. Our next tweak is to our layer heights. So when a 3D print fails, it almost always does between the interface of two layers, as this is where the molten plastic has to adhere to the previous cooled layer, and it's kind of like a wood grain. It's the weakest part of a 3D print. With that in mind, you can make your print stronger by slightly increasing the thickness of each layer so there's less interfaces. For example, here we're increasing our layer height from 0.15 to 0.25 millimeters. There is a downside to this change, which is the printer's accuracy. The stepping between layers will become more pronounced when increasing your layer height, but for this print we want to increase strength, so it's a pretty fair trade-off. It's also very important to note that you can go too far with this. Never exceed your nozzle diameter with your layer height or your part will just fall to bits. As I'm using a 0.4 millimeter nozzle here, 0.3 millimeter layer heights would probably be as coarse as you should go. Similarly, we can increase our extrusion width, which will produce thicker lines overall as more plastic comes out of the nozzle at once. Here I've set mine to 0.55 millimeters from a 0.4 millimeter nozzle versus the default of 0.48. You can also increase your extrusion multiplier to extrude more material overall, but be warned, if this is too high, you might seriously degrade your print quality. So here, I'm not going to increase it too much, I'll go from 0.9 to 1. One final tip to squeeze just that little bit more strength out of your parts is to consider increasing your print temperatures slightly. This can definitely help the layers of the print bond together more at the slight expense of detail being resolved. So don't go overboard, you may increase oozing or stringing with increase of temperature. Here I've changed from 190 degrees, which is standard PLA printing temperatures, to 205, and as an interesting side effect, my black PLA started looking satin, which is actually quite a nice finish. We've changed loads of settings to make our prints far stronger than the original, but there's one last thing you really should consider, which is our infill overlap percentage. This changes how far your infill overlaps the perimeters of the print. So if you're finding your infill is coming away from the inside faces of your print, then definitely change this setting because it's not doing very much good if it doesn't stick. However, I wouldn't recommend touching this if your infill already bonds correctly because there's no point messing with success. So let's put our prints to the test. As you can see here, the increased strength part is far superior in terms of durability than our original. It did use more plastic and weighs a little bit more, but really you're going to end up with a part that can stand up to everyday use and you're going to get a part that's going to last me for quite a few years and helps keep my cordless drill in an organized fashion. So thanks for watching, guys, and I hope you found this video on making stronger 3D printing parts useful. As you can see, simply increasing your infill percentage is not the whole story. There's lots of settings you can change to get a far superior strength part of your 3D printer. A big thanks to Simplify 3D for sponsoring this episode of 3D Printing 101 on Makers Muse. If you want to see future 3D printing tips, tricks, reviews, and more 3D Printing 101, be sure to subscribe. And don't forget to check out our previous episodes of 3D Printing 101 in our huge playlist to get you up and running in the wonderful world of 3D printing. Happy printing, guys, and I look forward to seeing you again very shortly. Catch you later. Bye.